Hi everybody, welcome to one more of Mrs. John's lesson. Today's lesson is just an introduction to DC electricity for year 13 physics. This is just covering the basic concepts that you already know from year 12 physics. So we're starting off with what about the two types of charges. There are only two types of charges. There's a positive charge and there's a negative charge. Now, the negative charge, the smallest amount of charge, is that held by an electron, and charges have a symbol of Q. So the charge on an electron is negative 1.6 times 10 to the power of negative 19 coulombs. And the charge on a proton is exactly the same as the charge on an electron. And that's also represented by Q, but it is positive, and it's positive 1.6 times 10 to the power of negative 19 coulomb. So the word is coulomb, which is the unit in which charge is measured. Now, all materials are made up of atoms, but the thing is, metals have very few valence electrons, and these electrons are free to move away from the atom, and these are the ones that move. Okay, now when you have a piece of conducting wire, so you have, usually wires are made of copper, most of them, or you could even have aluminium wires because aluminium is cheaper than copper. Nothing happens. But the moment you connect the ends of a wire to the terminals of a battery, okay, so what happens is there will be an electric field set up between the positive and negative terminals of the battery, and when there's an electric field, the charges, the electrons actually experience an electric force, and all of them start moving in the same direction. Now there is a relationship between the electric field strength, the electric force, and the size of the charge, and this is given by, so the size of the force experienced by charge depends on the electric field strength as well as the charge itself. Okay, so this is an electric force. The F stands for electric force, E stands for electric field strength, and Q is charge. You can also rearrange this equation and say that electric field strength is equal to F over Q. Okay, so those. Okay, now the thing is, charge, when that is free to flow, that's free to move in any direction, what actually happens is they lose electric potential energy if they are moving with the field, and charge that's moving against the field gains electric potential energy. So what does this all mean? So for example, if you have two metal plates, okay, so you've got plate here, plate there, and they are connected to the ends of a battery. So I'm just drawing. So the long line represents the positive terminal, and the little line represents the negative terminal. So the end of the plate connected to the positive terminal gets positively charged, and the end of the plate connected to the negative terminal gets negatively charged. The space in between, there is an electric field out here. And we always represent an electric field by drawing field lines, and the electric field between two parallel metal plates is uniform, and the way that we show a uniform field is by drawing parallel lines that are evenly spaced. So this is how you show, and you've got to draw arrows to show the direction of the electric field, and you can see my arrows are pointing from the positive to the negative. That means the direction of the electric field is actually the direction in which a positive charge will move. Unlike charges attract, so a positive charge will always move towards the negative plate. Okay. Now, if you place a negative charge over here, if you have an isolated negative charge, and if it is free to move, it will just freely move towards a positive plate because opposite charges attract each other, and it will actually accelerate towards a positive plate. Now, when it accelerates towards a positive plate, what it's gaining is speed, so it's going to gain kinetic energy and it's going to lose electric potential energy. So how can a charge be made to gain electric potential energy. It's forcing it to do something it doesn't want to do. So if you have a negative charge and if you have to force it to remain at the negative plate, it's going in a direction it doesn't want to move, and that's when it gains electric potential energy, when it's forced to move against the field, okay, where it normally wouldn't like to go. And the amount of electric potential energy gained, so that's represented by EP, which is equal to work done. Okay, and now you know that work done is force multiplied by distance moved. Now electric force, so this is an electric force, and we just learned, which I've just struck the board, that electric force is electric field strength times this, times the charge, times distance. So this is how you get electric potential energy. Now, and also the amount of energy held by charge is called voltage. So voltage is actually the amount of electric potential energy that each charge holds. And so if you divide both sides by Q, so I just divided this by Q, if I divide the other side also by Q, you end up with an equation for voltage which is equal to E times D. So that's how you get voltage, or in other words, the voltage across these two plates, the potential difference. This voltage is equal to electric field strength, and what does the D stand for? It's the distance between the plates, or the distance that the charge moves, okay? And then you have the other term, so we've done about voltage, we've done about electric potential energy, current. Now current, whenever you have charges flowing through a wire, you have a current, but the size of the current depends on the rate of flow of charge, how quickly charge moves. So current is given by, so I is for current is given by Q over T. Q is again charge, it could be capital Q or little q, and because of that, current has got two units. It's measured in amperes, or it's also measured in coulombs per second. So either of those is current. Again, voltage is measured in volts, okay, or it could also be joules per coulomb because it's the amount of energy carried by charge. And the last thing I'm just covering in this is about power. Power is how much of energy is used each second, how much electrical potential energy is used per second. So it's measured in watts, or it could also be measured in joules per second. Power can also be calculated, what we learned earlier, as voltage times current as well. So that is just an introduction to flow of charge and transfer of energy. So once you've listened to this and you've copied the notes, could you please do these questions on flow of charge and transfer of energy? Bye for now.